Merging with simulator in 3, 2, 1.
So the way this works is when the torch trigger is depressed, the plasma gas solenoid, it opens and gas begins to flow through the torch. Then high frequency is turned on and the pilot arc goes and contacts, right? Then the high frequency current ionizes the gas, and this is where an initial arc is created between the electrode and the nozzle. Okay, I hope you guys understand this. Let me see here. All right, so here it is. So here's our electricity, this red part here. That's how it's going down our electrode, okay? And here's our pilot arc, and as soon as that high frequency generator hits, boom, off it goes, okay? All right, here we go. Okay, so we're back and we're talking about starting the plasma process. So a pilot arc is a low current arc between the electrode tip and the nozzle in the torch head. Now when the torch hits close enough to the wort, the pilot arc jumps using your high frequency. Now almost instantly after the pilot arc jumps, the gap, the plasma current relay inside the power, it closes. It's closing our circuit, okay? Now once it closes, the plasma arc is established. As the plasma arc is established, the pilot arc contacts open and the pilot arc doesn't have to be on anymore, okay? The pilot arc is just there to start it. Now, the pilot arc is a really low current flow. Now, you do not want to run it a long time without starting the plasma arc because it can damage the electrode and the nozzle tip orifice. So, for good measure, be sure to turn on the plasma arc when you're ready to cut the material. Some individuals like pushing the trigger without starting the arc to see if everything's working, but it's not a really good practice and it can really wear your equipment out prematurely. Now this is super cool. Now because PAC doesn't rely on thermal conductivity like oxy-fuel, a bunch of sheets can be stacked and cut efficiently. It also can be necessary to make a weld along the sides of the stack in order for the cut to start consistently, but it can be done. Now with the oxy-fuel stack cutting, it's important that there's not any air between them, okay? So we can have little gaps in there and things like that. So it's pretty cool. Now, some people call DROSS slag, but DROSS is the metal compound that resolidifies and attaches itself to the bottom of the cut. Now, this metal compound is made up mostly of unoxidized metal, metal oxides, nitrides, and a bunch of gooey stuff, right? Stainless steel and aluminum are easily cut DROSS free. Now, carbon steel, copper, nickel copper alloys and such, they can be a lot more difficult because of their composition. All right, so just like oxy-fuel can be attached to a semi-automatic or automatic device, so can a plasma cutter. Now, high-powered PAC machines can have upwards of 1,000 amps. Now, there are large computer-controlled cutting machines made for PAC systems, and there are also robotic cutters that perform high-quality, high-volume cuts. Machine cutting generally will use water, but some hand torches can also be used in water. Now, the water reduces noise level, it controls the light, and it traps any types of sparks. It can eliminate most of the fumes. It also can reduce distortion. This is why water tables are used in larger pieces and production work. I think it's pretty cool anyhow. Okay, so we can contaminate the water around us. So we want to make sure to clean up well after you cut outdoors with PAC. If you do not clean up well, rainwater can actually wash away those fine metallic particles into our water system, and we don't want to do that. Here we go. Manual cutting. Manual means that you'll do the process by hand. Manual plasma arc cutting is really a very versatile process. It can be used in all positions and on almost all metals. Now, I found in my career that in the field, Plasma arc cutting is not as used as much as oxy-fuel or air carbon arc because of the electrical requirements and the requirement for compressed air. So not only that is considerably more than others, the types of cutting or gouging systems, okay? So sometimes we need to remember that. Okay, so let's talk about setting up for manual cut. So make any adjustments and changes to the electrode tip nozzle, or other torch component before the machine is powered on, because you can get shocked if the trigger is accidentally activated while you're servicing these parts. So make sure that it's off before you do that. Now make sure the work clamp, the ground clamp, is connected to a clean, unpainted spot on the metal that you're going to be cutting. Now we also want to see if there's anything behind the cut that'll block the sparks from falling free of the cut. Now, using a cutting table instead of a solid metal table is a good idea, you know. We also want to see if there's anything that'll be damaged or set on fire with the sparks. We never know, right? So, set the cutting amperage to maximum. Make a practice cut and see that the material can be cut cleanly. And reduce the amperage and make another cut. Now, we want to repeat this process until you have the amperage set as low as possible while still making a clean cut. Now, we need to remember, setting the amperage to the lowest possible level will actually extend the life of your torch parts like your electrode itself. So most often, straight cuts are made with PAC. Now, you can hold the torch close to the head because the head of the torch, it doesn't get as hot as an oxy torch. Okay, so and there's also fewer sparks when you cut thin metal. So when we use a straight edge as a guide, pay attention to the line you're cutting and how far away the center orifice is in relation to the cutting line. So sometimes the edge will push out the nozzle and away from where you want to cut. So pay attention to that. All right, so set the amperage to the lowest possible level to extend your torch parts. Piercing. Piercing a plate is important regardless of the process. So when you pierce a hole with plasma or even oxy fuel, you want to raise the torch about 1/4 to 1/2 inch. So the blow black from the dross or the molten metal doesn't plug the orifice in your tip. Okay. Another technique is to angle the torch just a little so you don't have blowback and you can get a running start from the edge. So you need to pierce a hole in the plate in order to make any type of interior shape that needs to be cut out. Now, when angling a torch, make sure you watch out for others or anything that can catch on fire. Now, if we look here, this is kind of a good picture. So we can see how it's angled just a little bit as it's coming in. And then as we're coming in, we can also turn it so that it's more up and down and we have a square curve. Now, when using a torch starting angle, you want to make sure that their sparks are directed away from people. So regardless of your technique that you use, be aware of your surroundings. This includes people or materials. You know, people can catch on fire too, occasionally. All right, so making a circle. Now, a lot of these techniques can be also used for oxy fuel. So, you know, kind of take that in consideration. Now, flat cutting a circle. So we want to make sure to draw your circle. I tend to use Sharpie because it doesn't rub off. For me, soapstone can rub off when I'm working, okay? So I call it the swirl method to make a hole. Now, we want to pierce the plate in the center, okay, right about here. Now we want to swirl the torch to the perimeter to where your circle is drawn. So I want to circle it out, and then I'm going to make it meet to where I want it to go. All right, and that's the best way to make a circle. Now you can also they have like these little wheels that you can stick on your plasma cutter that helps you make a perfect circle. But those of us who do not have that, that's how you would make a circle. All right, plasma arc gouging. Now, plasma arc gouging is similar to air carbon arc in that it can groove or cut out pieces of defect, damaged parts. Okay, so let me show you. So here they're using it to gouge out. Okay, they're using this to gouge out parts. Okay, so sometimes we need to cut round material like pipe, rods, or even bolts, but we want to make sure to point straight down and cut. Cut in the direction that it is pointed. Okay, so remember, we want to aim straight down. So if your aim isn't straight, the cut will have an angled edge. Beveling. Beveling means to put an angle. Now, you can cut by hand to create a bevel. In order to create a bevel, you tilt the head of the torch to the appropriate angle. Now, the picture on the right uses a piece of angle iron to guide. This is the greatest idea in the world, okay? It helps you drag it along and have the correct angle. Now, so when we work with pipe, in order to get a proper penetration, the pipe has to be beveled, right? So, since plasma can operate at any angle, it makes it perfect for cutting pipe. Now, we can see the pictures on the left. This is a pipe saddle. Instead of having an oxy-fuel torch, a plasma torch is being used. Now, pipe saddles can be rotated manually or by a drive motor. So let me show you here. So this one is actually being done by a hand crank, okay, and it's going all around the pipe. Now this one here, this one's being done by a drive motor, and you can see the little remote control the guy has in his hand. Pretty cool. All right, so overall, plasma cutting is becoming the most popular cutting process because it's cut so many different types of materials. Now, understanding how to master the correct travel speed can really be difficult, especially if you're new to this. Now, early plasma cutting systems required helium or an arc to create the plasma and shielding gases. Now, as the plasma process developed, there's less expensive gases and compressed air used, and the torches and power supplies have improved immensely. As always, guys, take care and weld the world.
Please like and subscribe. If there is something you would like to learn about, please leave it in the comments.
Weld the world.